Introduction to the 16-bit PIC24F microcontroller family from Microchip. Welcome to the training module on Microchip's PIC24 family introduction. This module will take a closer look at the capabilities of the PIC24F microcontrollers. The PIC24F is meant to be a cost-effective first step into 16-bit products. Microchip offers 4 16-bit families that share common core architectures, instruction set, development tools, peripherals, and pinouts. A designer using a Microchip 16-bit product can balance their controller selection based on cost, performance, peripherals, and even DSP capability. All 4 families use the same toolset, allowing smooth transition without the need to learn or purchase new tools. This continues from the previous slide, which shows pictorially the number of products present in the PIC24F, PIC24H, DSPIC30, DSPIC33F 16-bit families. The lower band indicates a continuation from the 16-bit controller line into the realm of 16-bit controllers. At the beginning of the band, with 16 MIPS, is PIC24F, the entry-level 16-bit product. The PIC24F provides a performance jump from the PIC18 microcontrollers with minimal cost impact. Next on the microcontroller band is the 24H, the highest performance 16-bit microcontroller with about 40 million instructions per second of performance. The upper band of our digital signal controller, or DSC product, is up to 40 MIPS performance and DSP instructions. Microchip's 16-bit product line is designed to rival many 32-bit controllers in performance with the ease of use typically associated with the 8-bit product lines. The common architecture makes it easy to optimize a design for cost and to reduce risk by providing speed, memory, and peripheral upgrade paths. All devices in Microchip's 16-bit product line use the same MPLAB Integrated Development Environment, IDE, and MPLAB ICD2 development tool chain shared by Microchip's 8-bit products. Using internal benchmarks based on industry standards and internal application code, Microchip's entry-level PIC24 family executes at 16 MHz with about 14 million instructions per second throughput, showing an advantage of the RISC architecture's single-cycle instruction execution. The graph shows the results of compiling C code with various C compilers for a number of processors. The code compiled was a combination of approximately 40,000 of application code used in various application notes. The higher the number, the larger the resulting program memory. A smaller number indicates better C code efficiency. All of the devices in the PIC24F family are built with the same base peripheral set. The primary difference being flash memory sizes, which include 64 kilobytes, 96 kilobytes, and 128 kilobytes. The devices start with the 16 MIPS PIC24F core. Around the core is a peripheral set that includes the 16 channels of 10-bit analog to digital converter and 2 analog comparators. The device includes a watchdog timer and 5 channels of 16-bit timers, 4 of which can be cascaded to form 2 32-bit timers. The PIC24F family also includes a real-time clock with calendar function that is often used for time-stamping data logged information or communications data. The devices also include 2 I2Cs, 2 UARTs, and 2 SPI channels. To complement the various serial channels, there is also a cyclic redundancy check, CRC, peripheral that can be used to ensure data or will be correctly communicated. PIC24F is a Harvard architecture which has separate data memory from program memory. Speed of the processor is 16 MIPS. When operating off a 32 MHz clock, the PIC24F can expect the performance to be roughly half of the clock rate, or equivalent to instruction execution time. In addition to faster execution time and 16-bit data bus, there are several other additions to the core. The interrupt structure of the PIC24F is significantly upgraded. The PIC24F provides an independent interrupt vector for each interrupt source. The PIC24F family provides 16 working registers. The PIC24F implements 16-bit math, including a 17 by 17-bit single-cycle multiply. The architecture also implements a single-cycle multiply bit shifter, or barrel shifter. The instruction set and addressing modes work to improve the PIC24F C code efficiency. Finally, the PIC24F core incorporates a repeat instruction. This instruction allows a math instruction or memory transfer instruction to be repeated a specified number of times. The PIC24F provides a natural migration path up from the PIC18. First, the PIC24F provides increased memory. On the first family, Microchip expands from the RAM from 8 kilobytes and the flash to 128 kilobytes. It would be a fair guess that the 128 kilobyte flash on the first family will not be the limit too long. Along with the increased memory is, of course, increased performance, with a 16-bit microcontroller operating at 16 MIPS. The device contains 5 16-bit timers, 4 of which can be cascaded to form 2 32-bit timers. There is also a new high-speed 10-bit analog-to-digital converter. The 10-bit analog-to-digital converter is capable of conversion rates up to 500,000 samples per second. JTAG boundary scan has been added to the PIC24 family to assist in board-level testing and in-system programming. The PIC24F CPU incorporates hardware support for both multiplication and division. This includes a dedicated hardware multiplier and support hardware for a 16-bit divisor. The PIC24F arithmetic logic unit is 16 bits wide and is capable of addition, subtraction, bit shifts, and logic operations. Depending on the operation, the ALU may affect the values of the carry, 0, negative, overflow, and digit carry status bits in the status register. This slide shows regarding the programmer's model of the working register. It has 16 working registers. Each is 16 bits wide, which are exclusively used during multiplication and division. Its program counter is 23 bits wide. PIC24F is a Harvard architecture device which consists of separate program and data and memory spaces and buses. This architecture allows the direct access of program memory from the data space during code execution. Program address space spans 4 meg instructions. It is addressable by a 24-bit value derived from a 23-bit program counter or from table operation or data space remapping. User access to program memory space is restricted to the lower half range, that is, from 0 hex to 7 FFFFF hex. The part number begins with PIC24FJ, which is a 16-bit entry-level PIC controller. The flash memory size immediately follows the FJ in the part number. The G indicates that the device is a general-purpose device. In the future, other designations will be added to match the feature set. The A0 are used to identify specific derivatives. The last two digits are a rough indication of the number of pins divided by 10. Microchip's PIC microcontrollers are supported by the MPLAB Integrated Development Environment, which is used to integrate development, debug, and software utilities available when debugging code for a product. MPLAB is the only platform you will need to develop for a Microchip microcontroller and can cover products from 6 pins to 100 pins and code space from 512 bytes to 256 kilobytes. Language tools are available from Microchip in the form of an assembler, a linker, and a C compiler. Development tool support also includes software simulators, emulators, development boards, and programmers. Available utilities such as Flash programming, project management, and MPLib librarian are also included in the MPLib IDE. Beyond the Microchip tool chain are a number of third-party tool vendors that also provide valuable tool capabilities such as compilers, production programmers, and software tools, including an RTOS, libraries, and device drivers. MPLab IDE is designed to work with all of Microchip's in-circuit emulators and programmers. The Microchip 16-bit families are supported by the MPLab ICD2, MPLab Real ICE, and the MPLab PM3 programmer. All of the tools are designed to work with MPLab. MPLab ICD2 is a flash upgradable in-circuit debugger designed to operate with any PIC microcontroller. The MPLab ICD2 can be connected to and powered by the USB connection on its host PC. It can also connect through a RS-232 port. As an in-circuit debugger, it will enable the device to single-step or set up to 3 breakpoints and then upload relevant data to the host PC. While the MPLab ICD2 can program a device, we also support the MPLab MP3 for low-volume production programming. The Explorer 16 board is designed to interface to the MPLab ICD2 to provide a complete development platform. The board includes a PIC24FJ128GA010 and a DSPIC33 DSC. The processors can be changed by changing the processor interconnect module, or PIM. The board includes the power supplies, buttons, switches, and displays that you would expect in a development board. It also includes a small prototyping area and a socket connector for use with the Microchip Pigtail, plus daughter boards. At this time, 2 daughter cards are available to quickly enable the Explorer 16 board to connect with an SD MMC card or to connect to Ethernet through a ENC28J60.